this morning we saw why all projects are impossible to finish on time, right? And so obviously big projects are completely impossible to finish on time, right? And a new building, a new big capital and construction project in particular cannot finish on time, right? I'd like to present Ian Heptinstall, who's going to explain to you why he does not agree and why you could finish all those projects as well on time.
Almost 20 years ago, I just finished working on a very successful project in the chemical industry in the UK. It was the exception to Philip's rule. So it was on time. It was under budget. The project client, the US chemical company Roman Haas, was delighted with the success. Nobody who worked on their factory could remember a project hitting its objectives before. The major suppliers involved in the project were delighted. They actually made much more profit than expected. The client paid less, the suppliers made more profit. The proverbial win-win. The project won a regional business award for supply chain excellence. But I wasn't very happy. And the reason that I wasn't very happy was the fault of this guy, Goldratt, who's been mentioned once or twice already today. Ellie Goldratt. Now, the reason that Ellie Goldratt was the reason I wasn't unhappy was because he had just published the book Critical Chain. Now, who's read Critical Chain, by the way? Hands up, so not quite as many as for the goal, but Critical Chain is the goal for projects. And I read Critical Chain in 1998, just as this project was coming to an end, and I thought, damn, if only he'd written it 3 years earlier, this project would have been even better. And I think Oded said this morning that one of the problems of people who are infected by TOC is on time, on budget, without changes is not good enough on a project. We want the fastest, the lowest cost project possible. We want the maximum value for money. Hitting budgets is easy. Now, I know many projects don't manage to achieve that. Maybe I was lucky in my early career as a project manager. Maybe I was lucky because I worked in the right project environment. And although I'll share some data on how capital and construction projects perform generally in the world, that was not actually the world that I inhabited. In the chemical industry, most of our projects were not late or over budget before Critical Chain. But when I came across Critical Chain, I thought, I wish I'd known this before. We could have got more projects for our limited capital budget. We could have brought plants online faster, whether that was to produce new product or to improve the safety and environmental performance. We could have done it sooner. That's the frustrated person in me. Then after I finished that successful project and had read Critical Chain, my career, as careers do, took a slightly different direction. 10 years later, so about 10 years ago, I found myself working as Chief Procurement Officer in the construction industry in the UK for a large contracting company. So I wasn't directly responsible for projects, but I was closely involved in projects. And what frustrated me at the time was looking at projects and thinking, the industry doesn't seem to have learnt. 10 years ago, Critical Chain came out. We actually did something else innovative on the project I mentioned that I'll talk about later in this presentation. They've not learnt from that either. So I started to get sort of frustrated. In 2010, when I left that job and moved into a consulting role, I spent some time researching and thinking about, well, why not? It's a good idea. It delivers fantastic results when it's implemented well. It's not difficult. So why hasn't the idea of Critical Chain just taken over the industry? Other things had taken over. when I started working on projects, computer screens were green and green. You know, light green and dark green. All of a sudden they were colour. Nobody resisted change. When I started working on projects, telephones had wires attached to the wall to them. 10 years later, telephones didn't have wires. Nobody resisted change. Even the construction industry. Many of you have probably got at home a thing called a hammer, used for putting nails into wood and other substances. Do construction projects use hammers these days? Hammers are electrically or pneumatically powered and go to put nails in. You do not see tradespeople with hammers to put nails in. Very few people use a saw and their hand to cut wood. You cut wood by going zzz, and put screws in. Go zzz. Innovation is not a problem in the construction industry at a local level. So the research thinking about why hasn't critical chain taken over this industry? It's not an industry full of money. Clients are not happy to sit back and wait even longer for their projects. So I started thinking about it, talking to as many people as I could, and I think I've come up with an idea why this type of project environment has very few examples of success in critical chain. So capital and construction projects, building things like big buildings, shops, hospitals, roads, railways, factories. It's enormous. Not only is GDP growing around the world, as Oded mentioned this morning, major projects, capital projects, is 8 to 10% of GDP in most countries. It's worth about at least $10 trillion a year, and it's forecast to grow at a greater rate than GDP. It's a fantastic opportunity for people who understand flow, projects, TOC, to help make some significant improvement. As we've seen before, if only life was that easy, then we'd all have a busy life. But it hasn't. And I'd like to share some of my thinking on maybe why in this industry critical chain has not had the success and the penetration that it could do, and more importantly, something that we might be able to do about it. So capital and construction projects are no different from any other project. The data says, you know, I'm the exception that proves the rule. The vast majority of projects are late and spend more than the original budget. In the public sector, by the way, there is an argument as to whether not achieving the budget is deliberate underestimation of the budget in order to get projects approved. That's another topic, but the research says at least half of this is nothing to do with people under budgeting. It's problems of execution. And if anything, performance seems to be going backwards. I think Johan mentioned some of his strategies to do with Internet of Things and 3D printing and digital that. And the construction industry is no different. You can read great reports from big brand consultancies, McKay as well, telling us that the problem with the construction is the lack of exploiting of modern day intervention. Now, I don't believe that that is a root cause at all. And in the proper scientific method, I will disprove that theory by just using one example. And this is an example from 90 years ago. Two very similar projects, both in New York. The Empire State Building, built in between 1929. Number one World Trade Center became New York's tallest building and was the replacement to the tragically lost Twin Towers. Very similar scale of buildings. The Empire State Building, sorry for the text that's changed, took 410 days to build. from starting on site to completion. It cost, in today's money, around $2,000 to $3,000 a square metre. Move forwards 90 years to a project that's got all the digital you can think of. It took 7.5 times as long to build it. It cost between 5 and 8 times more. The reason I can't be accurate is because extrapolating from $1930 to $2013 is not an exact science. There's a bit of guesswork involved. And that's per square metre of commercial area. So some significant differences. And this is not just because in the 1930s nobody cared about safety. You've probably all seen the picture of people having the lunch sitting on the girder swinging from the crane on the Chrysler building. The Empire State Building, by the way, had, for its time, exemplary safety statistics. It actually invested significantly in reducing health and safety incidents. Certainly it wasn't the norm at the time. But some of the things that the Empire State Building did are today called innovative modern methods of construction. It's a fantastic example of history repeating itself. They use competence-based selection of the team. The general contractor was selected 2 weeks after the architect. The architect didn't have time to put together a full set of plans and drawings to get a lump sum. The negotiation with the main contractor also took about 2 weeks. It was based on skill and competence, not an invented number. Using what today is called early contractor involvement, an innovative method of the 21st century. They had an overarching team goal. They made the maximum use of off-site standardized manufacture to minimize time on site. They put a lot of effort into design for construction and design to maximize commercial rental. Was all part of the package. It wasn't just focused on one little thing. Today, they did what lean construction has trademarked and called total value design. When you look at what they do, this is exactly what they did. But as is a common theme today and no doubt will be tomorrow, what they did do, almost everything you can see they did, was about focusing on flow. As we know, as Oded said, if you focus on the process flow, the flow of the right information and the flow of decisions, then project and production works very well. And I think that's something that the industry has lost. If I look at the methods used to manage and procure projects today, then flow is the last of people's priorities. And of course, I think in manufacturing, is it called Plossel's first law of manufacturing? That all the benefits to the people involved in supply chain are in proportion to how well things flow. If things don't flow, then the benefits reduce. And in project terms, the client gets lower return on investment and the supply chain has wafer-thin margins, as we see in all parts of the world. So, making projects flow is quite easy as well. Use critical chain. As we've seen from some of the presentations today, and certainly some of those later today and tomorrow, we will see from all sorts of business environments, this is not just playing with numbers, no, shuffling the plan around, halving things, adding a bit of buffer, hey presto, the project takes 30% less time. No, it's real, it works. If we can adjust how people are measured, which influences how they behave, we can make projects work much, much better. However, and there's a but, critical chain assumes we have a collaborative team in place, so that the idea of a common goal, common objective, shared contingencies and risk pools is easy. obviously those of you who've worked in that environment know it isn't easy, but it's much more difficult when we have contracts in the way. And in fact, what it seems to me is that the way that major projects are contracted, and remember, on a construction style project, probably 95% plus of the work is not done by the employees of the client. 95% of it has a contract in the way. And if those contracts inhibit collaboration, then it's almost impossible to implement critical chain. It can be done, but it's a very hands-on controlling role. You in effect rent resources by the day or the hour, and you tell them exactly what to do and you control them. If you want to use a contract to help manage that control, then the common methods of today, I'm afraid, don't work. Just like this slide, because I've just remembered I've used some font faces that haven't moved along. So this presentation is about what I would see as the major barrier to collaboration on this type of projects, which is how contracts are put in place, how the project team is procured and contracted. And I think that's the main barrier to one, collaboration, and therefore to using critical chain on the sorts of projects where most of the work is done by a third party. Now, if we look at the common ways of procuring, fixed price. Fixed prices are great if I'm buying a car or a house or a phone, but for something that's never been done before and might stretch out many years in the future, it's a very inefficient way of spending your money, in my opinion. Fixed prices incentivize and reward the wrong type of behaviors, particularly in construction. There's a truism quotation that's known almost all around the world. In English, contractors say, you bid to win, you make your money on the changes. You do not make profit on the bid price. But everybody knows the future is unpredictable, change will happen, that's where you make your money. It's one of the major, there are other significant issues with fixed price. It takes longer to put in place, it wastes time, it slows everything down, and it inhibits open communication. At the opposite extreme, a reimbursable contract. Give me a day, I'll pay you for a day. Give me a ton of concrete, I'll pay you for a ton of concrete. That also can drive the wrong behaviour. You've got conflicting requirements. The project client wants fewer hours. The project supplier, to maximise their profitability and shareholder return, wants maximum hours. So whichever of the common approaches you use, it also adds a layer of control, what I term contract policing. None of that helps the project be more successful. In fact, the more and more I look at construction project teams, more and more do I see the most highly paid, the most intelligent, the best educated people on the project are spending most of their time controlling their contract, not making the project flow. And as you'll know with organisations, the more people there are in the organisation, the more difficult it is, more communication. And then when most of them are not focusing on making the project better, you can see why a modern project takes 7 or 8 times as long and costs 7 or 8 times as much as one done where you didn't have that issue. And the third option that's sometimes used, particularly in this industry, is let's contract traditionally, but then we'll put the contracts away and we'll shake hands and we'll have a partnership charter. And because we've not got a gold tree in reception, in the project office we'll have our partnership charter that says we, the people on this project, will work together in the spirit of collaboration and be nice to each other and avoid disputes. And that's great. Until something goes wrong. And then everybody goes back to this drawer and gets the contract out and said, who can I make sure pays for this that isn't me? And that's where a lot of the time and effort goes. So what I want to present is a way to overcome that problem. And I know that some of you, even though you might not work in this type of project, this is a generic procurement and alignment approach that can work in other types of environment as well as projects. And it's something known as a project alliance. If you know anything about lean construction or have colleagues who work in the USA, the same thing is known as integrated project delivery, or IPD. Now, the idea of a project alliance is a commercial arrangement where you select the team based on competence, you get the team together, you make sure that the commercial rewards are driven by the project success. So there is no opportunity for one member of the alliance to have a commercial win and other members to lose. So the commercial success of all the alliance members are fully aligned. And there's a number of other features of an alliance, but basically you get a team together on a single contract with more than one party, the client, and some of the key members of the supply chain. Now, a bit of history, then I'll talk through a worked example based on a real case, a simple case. Now, it's a method that came to prominence in the 1990s in the oil and gas industry based out of the North Sea, which is actually very close to the history of critical chain, as I understand, where Statoil wanted to apply the ideas of the goal, but on something very different called a project. Project alliances were actually a different approach to the same problem. The problem that Statoil has was the same problem that the UK industry had, which is the oil price used to be here, and all of a sudden it fell. And they said, oh dear, if the oil price is there, there's no business case for getting the rest of the oil out. We will close down. So the whole industry said, let's improve. They had the burning bridge. They suddenly discovered that by contracting differently, they could deliver the same oil rig in 2/3 of the cost and in half the time without critical chain. So they could have done even better had they talked with the Norwegian side of the North Sea at the same time. On a traditional or a typical construction or a CapEx project, the client will basically enter into a single contract with a main contract to build what I want to build. They may have worked directly with some advisors and engineers and designers in the early stages to specify what they need, but they enter a single contract, and that main contractor buys services, subcontracts, there's sub-subcontracts. In today's market, main contractors do very little work. Well, they do work, but the gross margin of a main contractor, throughput in TOC terms, is about 15 to 20% of the contract value. 80 to 85% of the contract value is spent with other companies. Very few main contractors even have tradespeople doing any real work. They're like a wholesaler. The idea of an alliance does away with that and says, let's get a number of companies who actually do most of the work on the project together into a contract with the client, and we will contract in it as a team. We will have our performance measured as a team, and we will either all succeed together or fail together as a team. On this image I've shown 4 suppliers. It can be anywhere from 1 or 2 or 3 up to 10, 15, 20. But the idea is you get the companies who are going to do most of the work together without a middle person in there just adding 15% tax. Now, of course, they will have to let subcontract and equipment purchasers, because they don't cover 100% of everything, which can either be done traditionally or might be integrated into the shared risk and reward scheme that I'm going to use in the example coming up. So, a multi-party contract, the team selected for their skill and competence, not for a number that they've made up. Okay, the example I want to use now is the commercial mechanism that I would use to make the alliance work. Exactly how do you align the commercial interests of a team of suppliers and a client? And here's a method. It's a method that I call CFV, stands for the 3 constituent parts of what the suppliers paid. They are paid their cost, they will be paid a fixed fee for the job, and they will be paid a variable fee which will depend how well the whole project goes. Sorry about the colours. By cost, that means truly variable cost, that the money goes straight through the bank account. It's not invoice plus 5.3%. It's if I've got to pay something as an invoice, the project client simply reimburses that and the money is passed on. It will also include the salaries of people who work full-time on the project. But you're talking the money, cash, ends up in the employee's bank account or for pension or the healthcare provider. None of it stops within the alliance member. The alliance member's throughput, their gross margin, is either part of a fixed fee, which is agreed in money. The fixed fee is not a fixed percentage of their cost. It's fixed in dollars, euros, pounds, whatever. Could be 0. The variable fee is what links all the members together. They might have a different nominal amount, but each of the different suppliers involved, the amount they get paid goes up and down in harmony. And that's what I'll use in a worked example, which is actually from that project that completed 20 years ago, that I felt frustrated when I read Critical Chain too late. As I said, this was in the chemical industry. In today's terms, it's about $30 million project. So not a massive capital project, but not tiny either. It was a 3-party contract. To select the members took 4 weeks. Does anybody here have experience in construction? How often does it take 4 weeks to select somebody to do several $1 million worth of work? No, yeah. Might start, even 4 months is a bit short, isn't it? Yeah, typically. The request for proposal document was 3 pages. At the time, you measured the size of the documentation in boxes, because we didn't have CDs or DVDs at the time. It was physical paper. It wasn't 3 files, it was 3 boxes of files. Because you did all the detail, and you had to give the detail if you wanted a fixed price. And because contractors didn't do any work, they had to send inquiries off to their suppliers, and it takes forever. But if you're selecting based on competence and are willing to sign up to a target, you can do that much faster. And there's lots of benefits that come from fast competence-based selection. And the way that the parties were paid, so this is a simple case with 1 client and 2 supply partners. One of the companies did the engineering design and bought the equipment. The other one did some construction and managed the whole of the construction site. So this isn't to scale, but there's a breakdown of a traditional estimate for a project. There's something for designing and engineering, there's some equipment, there's some construction, there's some contingencies, because good practice always has a buffer. Always did in project management, but normally the buffer was money. Critical chain introduced buffer for time. So that total amount for the project was reconfigured. As it says, this isn't to scale. Yeah, thanks. There's the amount that was expected to be spent with third parties, the amount that was expected to be spent on salaries. So that is the cost. Whatever cost was incurred was reimbursed with the client. No cap. If the contractor spent 10 times as much, the client was obliged to spend 10 times as much. Now, that isn't going to happen, and there are some safety nets for the client, but in theory, it could do. So the blue and the brown represent the two companies involved. So they had a different fixed fee, and of course the variable fee is just shown here indicatively, because the actual variable fee could have been 0, could have been more, depends how well the project went. And I'll show you how that was worked out. In TOC terms, we've got the truly variable cost and the throughput of the alliance members. The variable fees on this project were put at risk against 5 measures of performance. Safety, when the project was finished, how long the plant was shut down for, because like the example this morning, there were 2 dimensions. The product was already being sold, but they wanted to improve its quality. So they wanted to improve that quality quickly, but they could only shut it down for a limited amount of time because they didn't want to lose sales. So that's why there's a shutdown and a schedule. If there was the cost, of course the client wants it to cost as little as possible. And there was a 5th measure called behaviours. I can share if anybody's interested. And these are the actual ratios used to divide the fee at risk. And in this case, it was very approximately the net profit of the companies that they would expect to make on a project like this was at risk against performance. And I'll use the numbers. At the time, so I've not inflated these, it was very roughly £300,000 that was at risk. Company 1 had 200 and company 2 had 100. So in total we had 300,000 at risk. Those 25% showed we had a nominal value. Now what that meant is if safety hit the agreed target, then £90,000 would be paid against safety. Obviously, 2/3 of that to company 1, 1/3 to company 2. So the same the whole way through. If we hit the cost target, £60,000 was put into the pot and then divided in the ratio. The actual payments on the project look like this. So the profit paid was 60% more. Now, some people who are not used to the construction industry look at these numbers and say, oh, but that's nothing. You know, it's a tiny amount. In a project that in those days was probably $16 million, just over £10 million, this is a tiny proportion. But these companies work on those tiny margins. What this small number is saying is those companies made 60% more profit than they would expect to do on this job. Now, if that's multiplied across the whole company, that's a dramatic impact on the bottom line. So although it's a small number for the client and the project, it's a dramatic leveraged impact on the suppliers. And here's some examples. These numbers are different, by the way. It's taken from a different source. I put them up here to remind me that I bought some piles of books. There were some out at the front. I do not want to carry them back home on the aeroplane. There's at least one each. If you'd like to find out a little bit more, please grab one. Even if you don't work in construction, you never know who you will be sitting next to on the aeroplane or the train going back. Just give it to them. Leave it in the airline lounge. I don't mind. The more people start thinking about this, the better, I think, for the economies and for all of us. So, time. Very simple. If you hit that date, the team gets this much money. Obviously, in my previous example, this would have said, whatever it was, £65,000. This is just numbers from a different project. If you finish earlier, you'll get paid more. If you finish later, you'll get paid less. Now, what we found, because our client was an American company, have we got any Americans in the room, by the way? So if you're watching on the video, please close your ears for the moment. No, the American client liked the idea of a penalty. So rather than just the variable fee going to zero, we had to write the contract so that it was, you always get this amount, and then we will penalise you and take it off you. And then they were quite happy. Mathematically, it was the same thing, but we had to present it in a way that made people feel comfortable. If any of you know English law and American law, the contract didn't use the word penalties because that wouldn't be enforceable if it went to a court. Variable fees are fine. Just the word penalty, lawyers avoid it in case you get a judge on a bad day, because that's how the law works. Law is not science. There's a little bit of logic and a little bit of science, but most of it is witchcraft, smoke and mirrors, is what I've discovered. The same with cost. If the project costs more, the partners make less money. If the project costs less, there's a gain and pain sharing. The way that we measured safety, by the way, is we developed a safety index where the efforts made and the management efforts and the safety program on site and whether it was stuck to gave you credits, and any serious nasty injuries reduced the index, so that there was a balance of rewarding effort and results. And that was done using an index. Behaviour, it was predefined as a word model set of behaviours. If the supply members behaved like a good traditional contractor, they just got the variable fee. If people perceived the behaviours were exactly the same as an excellent employee of the client, they got more money. And if they perceived that they were the worst of the worst contractors, they got less money. So that was a survey at the end of the project. Now, the project I talked about used 5 particular performance measures. There's all sorts of others that have been used, from life cycle cost to the operating efficiency of production plants to the impression of guests using a hotel. Whatever is important to the client has to be incorporated into the performance measures, because that's how you get the alignment of the interests. There are ways of doing this that, in my view, don't work very well, so you do have to think about it a little bit. There's many projects that make the performance payments linked to cost saving. So the project has to make a cost saving, and then if you're ahead of schedule, we'll give you more of that. I don't believe that's the right thing to do, because cost is very rarely the most important thing. And if you deliver a project on budget, but it's 3 months early and the client can exploit it, why should the client benefit and the suppliers not? That's not the spirit of aligning interests. Okay, so I've put a slide up that just summarises the idea of separating cost, fixed and variable. Of course, being a major project, there will be changes. But the majority of contractual changes are much, much, much smaller than the quantity on a traditional construction project, and they're easily accommodated. All you do is move the target to the extent it's changed because of the change, and you may change the fixed fee. You just say, if this was in the scope at the beginning, what would the fixed fee be, and what would the target and the nominal variable fee be? So each of the companies is together in a pot. The pot can get bigger, or it can get smaller and disappear entirely. But the beauty of this is that as soon as the project is underway, the focus, the commercial focus, is let's make the project successful. That works brilliantly. That move by itself saved the client of the project I mentioned about 5% of the project value, because they were going to get one of their US-based engineers to be an expat in the UK for 2 years, and with a traditional type contract, he would have employed a cost consultant or quantity surveyor to check through all the details to make sure that the contractors aren't stealing our money, because that's how the industry works. Just not having those two resources saved them nearly 5% of the project, because they trusted the companies through the aligned interests. Now, there's a lot more to making a collaborative team work than just a little bit of paper and some payment. Of course there is. That's maybe a discussion for another day. One of the things I do want to mention, however, is just because you are selecting the alliance members early and without a fixed fee, that doesn't mean there's no market competition. It's perfectly compatible with public sector procurement rules in most parts of the world. Some of the US states have a problem because the procurement law says all contracts shall be between the government body and a single supplier. But also the states have, unless it's approved by somebody. So there is always a way out if there's good business sense. So traditionally, you're doing late selection, detailed bids, and often you will select the lowest price bid. With an alliance, you're selecting the members as early as possible, get the team together early, don't leave it late, select based on competence, but that's still a competition. The capability and the experience of the people in the companies, you select the team together, align the commercials, and then it's easy. I've covered most of those things. Now, a project alliance by itself will deliver benefits. That's where the case studies are. Alliances used by themselves. That was my example at the beginning. And if you look at the history of alliances, or IPD, you'll see US healthcare companies that have used it to build new hospitals and refurbish old hospitals. And over more than 20 separate projects, they've got 95% on time, on budget performance. Again, unknown in industry, without critical chain, and without padding the programs and budgets, just by aligning the teams and removing waste. It's not automatic. You can't just get people together and say you're a team now and just assume that things will work out. It needs working on. You need to exploit the collaboration, which is where I believe that CCPM has a fantastic role and opportunity. It only works with a collaborative team, and as we know, if you can use CCPM on a project, you'll get the same project on time in less time, on budget at a lower budget, without having to compromise on scope or quality. But also, it's a fantastic foundation to use a range of other value improving and value enhancing techniques that will differ from domain to domain. I'm sure if I worked in IT, there would be ideas for making projects better. In the construction industry, there's lots of recommendations for good ideas that will work well. But almost without exception, they're not being implemented today for exactly the same reason that critical chain isn't being implemented, because the project team is fragmented and has got misaligned incentives. So that's my summary of how I think the project industry, particularly where projects are done with contracts in the way, can start to exploit critical chain and make some significant improvements. Remove the commercial obstacles to collaboration. That'll give you a foundation of teamwork onto which you can build and use techniques like critical chain, which exploit collaboration, but also they reinforce collaborative practices with daily stand-up meetings, with frequent reporting, with project managers saying, how can I help? Rather than, why the heck didn't you hit your target and your budget? Which will deliver the same project in less time, at lower cost, which if it's done well is the win-win for the industry. The clients get improved return on investment, and the supply chain are working at lower risk, and they're making better profit margins at the lower costs that they can deliver projects for. That's all I wanted to talk about. I hope there's been some interest in there, and maybe if there's any questions, we'll take those now. Thank you.
Can I just point out one thing, is that Ian's focus is on capital and construction projects, right? But there is some of this in nearly all projects, and it tends to grow. Just to give you a couple of examples from the last 2 years, of a major new part of an aeroplane where it turned out that there was an important software development that needed to be done, and they decided they didn't have the software competencies within the house, and so they subcontracted out to outside the company for that software. It was the critical chain, and it was contracted as with all the problems involved. So basically, the project couldn't be speeded up because of the way it was initially contracted, right? Another one we've done recently is the people who make water meters. In the development of new water meters, they have to get the mold made for the housing of the water meter, and 35% of the critical chain was the people who made the molds. It was outside, right? And they couldn't reduce those times because you can't go to a contractor and say, you know, I've listened to this Englishman in a conference about theory constraints, and maybe we could do it twice as fast. Okay, so he's talking specifically about those big projects like that, but some of this you'll find in nearly all projects. Thank you. Questions?